have discussed the distinction between probability distribution and the frequency distribution. So I have clarified that thing by quoting the example of, let's say, by taking the reference of US census. Let me show it again so you can recall the things that we had done last time. Okay, Abhishek. Okay, I'll surely do that again. Okay, which chapter? Okay, let me just please name the chapter also, because I haven't at least opened the book yet. So let me just keep it open. So this is decision science, and okay, so things are ready to go. Yes. So today we are going to talk about discrete probability distribution. Okay, where it is? Probability distribution. The page number 150 starts from page number 150. The chapter number is 5. Okay. So again, there are variety of distributions. What basically distribution theory is. So last time we have discussed this particular example, if you remember, just after that huge discussion on probability and the ways to 3 different ways to determine the probability. Last time we had done this, if you remember. So this is a US census data. So this is a 1 person's household, 2 person's household, 3 person's household, and their numbers, and then we just try to calculate the relative frequency, which can be renamed, or which can be say that it's a probability. Okay, so relative, if we say that okay, it's a relative probability, sorry, it's a relative frequency kahe ya to probability kahe, wo ek hi hai. So we just, based on that, we just try to understand that okay, what is the proportion of let's say what percentage of total households in US are the 1 person's household. Okay, so this is how we just seen this. Let's say what percentage of households are 7 or more persons household. Okay, so in US, the 7 persons household proportion is very less. It's only 1.2% out of the total number of household. And majorly, we ended the session with this discussion that if your goal is to identify the pattern, see, once you identify the pattern from the data, definitely you'll try to expand the series, or if you'll try to at least take something out. I mean, you'll try to infer something, you'll try to assume something, try to predict something basically. So why do we at least identify the pattern? What is the purpose of identifying the pattern? So we can at least understand the behavior of some observations. We can answer that what are the chances that this observation will keep appearing again and again in the data. Okay, so there are many aspects. We are trying to identify the pattern because we want to understand the holistic view of the entire data, and we want to predict something. We want to make an assessment that what are the chances of certain events will take place again and again. Okay, so I have shown that okay, this is the frequency distribution of 1 person, 2 person, 3 person, 4 person, 5 person's household. Based on the frequency, this is what the pattern I got, and based on the probability, this is what I had observed. So there is no difference if you plot the probability. If you let's say identify the pattern based on the probability being calculated for all the observations, or you use simple frequency, there's no difference. Okay, they all, I mean, the pattern won't get changed. Okay, so now we understood that. Later on we tried that okay, any graph you observe, if you plot the data and if you observe a line or circle, or let's say a bell-shaped curve, whatever you at least whatever the pattern you observe, okay, has something, some justification, which is called mathematical justification. You have to express that relationship, that pattern, mathematically. Okay, and if you do that, it's called PDF. Last time I've told you that it's called probability mass function. Okay, probability mass function is nothing but the mathematical function of, if you observe a line, if you observe a bell-shaped curve, the equation in proper terms, if I say that the mathematical equation of this is nothing but the probability mass function. Okay, so whatever pattern you observe, it's with you, but if you express it mathematically, it's chapter 5. It's chapter 5, Sonali. If you express this graph mathematically, okay, mathematically, then you can find out some more probabilities. Okay, probabilities regarding any observation that may appear again. Okay, so this is the beauty. If you simply plot the data, if you simply plot the data, you'll get the observe the graph only, you'll get the pattern only. But if you express mathematically, then you can answer many questions which haven't been answered before. Okay, so this is a beauty. So probability distribution, when I say probability distribution, what is a probability distribution? So any data you choose, no matter whether it is a GDP data, it's any quantitative data containing some variables, will have certain observations. What are the probabilities that this observation, that observation will take place again? So let me just at least discuss like this way. Let me just give you the rough idea about the probability distribution. What is a statistical probability distribution and why we are studying it? So basically, if we have, let's say, data just like this way, let's say this is column 1, this is variable 2, this is 3, 4, 5, 9, 8, 7. It's filled with the numbers, okay? 10, 11, 12, any data you, okay? It's like the size is like depending on the study, okay? So what are the probability that this observation will appear again? What is the probability that this observation will again? What are the chances that this observation will be seen again? What are the chances that this observation will take place again? Okay, what are the chances that this will be repeated after some time? Okay, so everywhere the probabilities can be calculated if you identify pattern and associate this graph. So based on the raw data, you can get pattern. Based on the raw data, you can get pattern. But if you relate with a mathematical form, okay, you can answer in terms of probability of many occurrences, many events. Okay, what are the chances that values would be, what are the chances that 8 will be seen 10 times? What are the chances that 7 will never appear again? Okay, only one time. Once 7 is seen, it's not going to appear again. Many such answers you can identify. Okay, if you have a mathematical form. Raw data can be used for the graphical representation or the pattern recognition, and the mathematical form which can justify that graph can be used further for the probability calculations, in a way, for some of the speculations. I hope you understood the meaning of this. Now, figures can be observed. Quantitative observation can be of two types. It's a discrete figure. This is called discrete. 8 to 10, 10 to 9, 10 to 15. These are the continuous figure. These are the continuous. These are the discrete. A distribution theory. So theories deal with the theories deal. So though if we talk about those probability theories deal with the discrete figures, they are known as probability discrete probability distributions. Now, those probability theories which are given in chapter 5, which are dealing with continuous data, they can be known as, yes, justly, correctly understood. So single value A fixed value is a discrete figure. The range of a number is called continuous, correctly identified by the Jocelyn. Okay. Now let's move further. Just a second. Oh, I have stopped share. Okay. Now let's talk about one particular okay, this is a probability mass function. This is a mathematical definition. If random variable x, assume values like x1 can be 5, x2 can be 7, x3 can be 8, and so on. And if they are the real numbers and they call observations, then the probability of occurrence of each observation can be denoted by p of xi. Probability of 5, probability of 7 will appear again, probability that 8 will appear again. So pxi denotes the probability of each observation. Okay. And if you let's say consider all the probabilities associated with each and every observation's occurrence. Okay. And if you identify a mathematical, let's say, justification for that, okay, that's a distribution. Now there are many distributions. As I said, that based on the pattern, distributions are different. Okay, for a straight line, you would have a different equation. Okay, for a curve, you'll have a different equation. Okay, for this exponential, you'll have a different equation. Okay, so that's why distributions are different based on the pattern you get. Okay. So let's study some of the distribution theories. Okay. Say for example, binomial distribution. So here the binomial distribution occurs when the variable naturally exists only two categories. Again, there are certain limitations. Limitations of theories. Okay. Every distributions cannot fit in all, experiments. No. Experiment wise, okay, you have to study based on the experiment, you have to study the limitations of the binomial or the any distribution. If you feel that can be that particular distribution can be, or let's say might fit into your data. Okay. So initially you can assume something. Okay. So initially you can assume that, okay, a particular distribution being followed by your data. Okay. You have to confirm it. Okay, I'll take some examples so you'll at least understand about this. Now, what is the limitation of binomial distribution? Or you can say the characteristics. This is applicable when there is only two possible outcomes. So any experiment, in any experiment, when there are only two outcomes, just like a tossing of a coin, either heads will occur or tail will occur. Okay, let's say birth of a child. Okay, male or female child. Okay, yes, just like that. Let's say there is a life testing procedure of bulbs. Okay, life testing procedure of bulbs. Either bulb will be functioning properly or it will be defective. Okay, it will be defective. Got this? So these kind of experiments are always producing two type of outcomes. So here the possibilities are two. Let's say if you are testing a microprocessor, let's say i7, in one production run, let's say 100 microprocessors are there. Okay, let's say that this is the first one, this is the second one. Okay, when you taste this can be either okay or defective. This can be either okay or defective. Okay, so same way. So here there are two outcomes. One is okay, another one is defective. So here in this kind of experiments, binomial distribution can be fit in, but again, you have to check whether your data follows, or let's say binomial distribution or not. Okay. Uh, so let me just show you the mathematical function of my binomial distribution. And let's talk about the binomial distribution with this. So here, this is a mathematical form of, if you want to find out the probability of any occurrence in the binomial data, okay, the mathematically it can be found out just like this by following this equation. You have to substitute values into this equation, and let's say if I want to understand that out of 100, let's say how many times, let's say 7 microprocessors are like defective. What are the chances that 7 microprocessors in a run, in a one production run of 100 microprocessors are defective? Okay, 7 out of, oh, sorry, 100 out of 7 are defective. Got this? If you identify the probability, if you want to identify the probability, and if your data follows, if in your experiment binomial distribution can be fit in, then you can identify the probability based on this formula. Let's try to understand what are the different notations. N denotes the number of fixed number of trials. Here the trials are fixed. Okay, so it's not like that, oh, you just continue the experiment, you just can, let's say in your company, let's say if you don't have, let's say you are running a manufacturing firm, okay, which basically manufactures LED bulbs, and you are conducting a live testing experiment of the bulbs, LED bulbs, and let's say you don't have data, or let's say in a day, let's say you have 7 production runs. Okay, in each production run, there are 100 units of bulbs. Okay, so this way, let's talk about one production run of 100 bulbs. So total number of trials are what? One production run, and there are 100 bulbs. Your objective is to check the life of bulbs. How many times you'll check the bulbs? How many times you'll check the bulbs? Here, experiment is regarding checking the life of the bulb, whether the manufactured bulb is working or not. Once, but there are 100 bulbs, 100 units. So you check the bulb 100 times, right? Aishwarya, 100 unit test. So trials, this is called trials. So trials are fixed. Okay. Now, P is what? Probability of failure. Now, a probability of, let's say bulb is working, it's 0.5. Maybe, let's assume that 50% chances. Let's say being an expert, you are saying that 50% chances are there that my bulb, okay, in my company, if I am manufacturing LED bulbs, 50% chances that the bulb will be functioning. Okay, if you are saying that, the probability that the bulb is functioning properly is 0.50, and the probability of failure, which can be denoted by Q, is 0.50. If 50% chances are there that the bulb is functioning, so almost 50% chances that bulb won't be functioning. Okay, what is X here? X is what? Number of failure events. Number of failure events. Out of 100, imagine that 30 bulbs are not functioning properly. So this is your N, this is your X. Got the clarity? Yes or no? Got the clarity? Each trial has two possible outcomes, success and failure. Okay. If failure is observed, X value will be counted. X can be 2, X can be 2, X can be 3, 3 time failure, X can be 4, 4 time failure, X can be 5, 5 time failure. Okay. N is a total number of trial. Okay. Understood? Can we go ahead? So here trials are fixed. Okay. Now, okay. So there's a person. Okay. Mr. X, or we can say that Mr. Pet. So Mr. Pet is not a good, I mean, we are not labeling it, just a simple example. So Mr. Pet is not a good student, okay? Or let's say he's just weak in the statistics, okay? Now, he just stuck somewhere because he had to apply, he had to appear in a test, okay? So in that test, he had to face 10 questions. 10 questions. He had decided that, oh, I go with my own assumption. I randomly tick mark the answers, right? Maybe if Mr. Pat would be an Indian student, okay, he would be, chanting the name of a favorite movie star or a god, or there are multiple options, okay? So with the name of the favorite character, okay, Mr. Pat would be check mark against the boxes randomly. Each question is containing 5 options, A, B, C, D, E. There are total 10 questions. Every time, if this person is going to mark the answers randomly, we need to at least draw the chart of probabilities, that what are the chances that this person will get 1 mark, 2 mark, 3 mark, 4 mark, 5 mark. We need to identify the probabilities. Okay. So let's understand that how this can be done. So my question here is, if randomly based on his own guesswork, okay, if he is going to tick mark all 10 answers, where in each question there are 5 options, out of which 1 is correct and 4 are incorrect. This way, what are the chances that he would get 5 answers correct? 5 answers correct out of 10. I want to understand this probability. I want to determine it. Okay. In what way I can do it? I can use, okay. So these are the conditions of the binomial distribution. The trials are finite numbers. Okay. Here there are 10 trials because he's going to assume 10 times, right? For each question, he's going to assume something randomly. 10 random trials are there because he's marking the answers randomly. So definitely there could be 10 attempts, 10 random attempts, 10 trials. Okay. Now, probability of success is what? Okay, what is the probability of correct answer? After A, B, C, D, and E, there are 5 options. Out of which, okay, only 1 is correct. So what is the probability of correct answer? It's 1 by 5. What is the probability of wrong answer? What is the probability of wrong answer? 1 minus 1 by 5. 1 by 5 is what? 0.20. 20% chances that answer is correct and 80% chances that answers are wrong. Why? Because if you randomly tick mark the answer, there are 4 wrong options and only 1 correct option. So this way, 20% options are correct and 80% options are incorrect. Got this? Clear? Now, These are the probabilities. Okay. Now, this is not a proper word. What should be here? This is not a proper word. What should be there? What is a probability? Yes, probability is 0.1074. Let's say he randomly tick mark the answers and the 0 answers are correct. None of the answer is correct. 10 times randomly he just tick mark the answers, and then at the end of the day he found that, oh, he has scored 0 marks. Means all the randomly tick mark answers are wrong. Chances are 10.74% with the binomial distribution. The probability is 0.1074. How? I'll at least show you. Don't ask me that question how. I'm going to show you that. Okay, I'll at least explain the calculation, but just try to understand the result first. Will help you to understand these probabilities. What are the chances that randomly he just tick mark the answer on, at the end he just got 1 mark, 1 out of 10. These are the marks, you can say, marks scored. The probability is 0.2684. Randomly, if you tick mark the answers, definitely, because there are only 5 options. 4 are wrong, 1 is correct. Definitely, at least one answer to will be correct, right? At 26.884% marks are the chances. Okay. What are the chances that he may secure 2 marks? Chances are 30% and the probability is 3020. 0.3020. Tell me the chances of 3 marks. Now probability is getting down 2013. What are the chances that the person the PAT will receive? I mean, PAT will score 4 marks based on a random guess. You need to have a super luck. Okay. The probability is 0.08. Tell me all answers correct. The probability is not nil. It's not nil. Okay. It's not nil. It's 0.00000 something. This is called super duper luck. That you just get 10 out of 10. That's a very rare event in this universe that we are living. Can you understand? Do you think this is possible? Let's say if the super okay, 9 answer is also like a miracle. Okay, probability is very less, Aishwarya. That's what I'm just trying to say. If you let's say if supernatural power is supporting you, then based on the random guesswork, if you get 9 out of 10, sorry, yes, 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 Aishwarya, yes, possibility is also very low probability. Yes, Aishwarya, correctly said by the Aishwarya, that these are the events which are rare events. Here the possibilities, they are not impossible thing, but the possibilities and the probability that this 2 events may take place is like very less, very less. Correctly said by the Aishwarya Tiwari. Okay, we are not saying the probability, as I said, the probability is not nil, but it's 0.000 something. Okay, 8 out of 10. Okay, so now coming back to my question, what is the probability that you would secure exactly 5 marks out of 10? Based on the binomial distribution, you can answer this. The chances are 2.64%, and the probability is 0.0264. Now, how do we calculate this? Okay, how do we calculate this? Because we know that binomial distribution can fit here. Why? Because there are only 2 possible outcomes. Which are the 2 possible outcomes? Either the answer will be Either the randomly tick mark answer is correct or randomly tick mark answer is wrong. Okay? Agree? Now, you have studied the concept of permutation and the combination, right? You have studied the concept of permutation and the combination. So when I say, just so when I say that, okay, the pad got 1 mark out of 10. Okay, 1 mark out of 10. Can you tell me the possibilities? Which particular answer would be correct? If he got 1 out of 10, can you tell me the possibility which answer could be correct? There are 10 questions. Which particular question? Oh, we need to use, no, Aishwarya, we need to use combination, I guess. Combination. We need to use permutation or combination. Think about it. Permutation or combination? It's a combination, Aishwarya. Combination. Here, order is not playing any significant role. Combination. So this can be correct, this can be correct, this can be question 1 can be correct, question 2 may be correct, question 3 may be correct, question 4 may be correct. Anyone. Here we have a 10 choices. Out of 10, let's say anyone could be correct. So that can be explained mathematically. We need to explain that mathematically. We have a 10 choices. That person pet has 10 choices. Out of 10, only 1 is correct. Okay? या तो क्वेश्चन 1, 2, 3, 4 उन सब में से कोई एक क्वेश्चन करेक्ट हो सकता है, लेकिन वो कोई भी हो सकता है randomly because the person is marking the answers randomly. Okay, now here it's 9 factorial. If we simplify this, this is 10. Okay, 10 choices. What is new in this? We have already identified the 10 choices from here based on our common sense. So why do we need this formula? For the simple, okay, you can, this is a very simple situation when only 1 answer is correct out of 10. That's why it's very easy to at least visualize the choices for correct answer. But when you have a 2, you do require this formula. When you have a 3 correct answers, again, you'll have to depend on the formula. Okay, so here you can imagine 10 different choices clearly within a second in your mind. But in case of 2 correct answers out of 10, still you can imagine. But for 3, you can't imagine all the combinations in your mind. Okay, that's why we need to rely on this formula. Okay, in order to understand the choices, the combinations of correct answers in this random guesswork exercise. Okay. Now, we need to associate, if let's say a person has secured only 1 marks out of 10, the 10 different choices are there, 10 choices are there, but we need to associate the probability of success. Okay, what is the probability of success? We have seen this concept, right? Have you seen this? Have you seen this? P is called probability of success. Okay, we have seen this. Okay, okay, so P, we need to associate P. This is a 10. This is a 0.20 probability of success. This is a probability of We need to understand the probability of failure also, which is denoted by Q. Okay. And that is 0.80. So probability of failure. Okay. Probability of failure. Now you just tell me, if we are going to do this, if we understand mathematics, this is called what? This is a PMF. We have studied. So this is a very simple structure of PMF. This is what? PMF, right? So logic is trying, logic of this helping us to define the probability mass function. 10 choices can be explained mathematically by combination formula. Okay, by combination formula. So this is n factorial, x factorial, n minus x factorial. This is what? Probability of success, helping us to probability of success divide into the power number of time you got success. Probability of failure, number of time you get failure. Okay, this is the thing. X is number of success, n minus x is number of failures. Great. So that's the only reason I have designed this table just like this way. So here p raised to x is what? 1. Why p raised to x is 1? This is like 0.2 raised to 1. Now this is what? 0.80 raised to 10 minus 1. That is 9. And you have to multiply this. 1 multiplied by 1 multiply. You have to multiply these 3 quantities. So you'll get this value called 0.1073. और ये कुछ भी नहीं है, ये वही है जो मैंने यहाँ पे लिखा था. Aishwarya is asking, this requires calculator. Can we use it in exam? Yes, of course, you'll have to. Because based on this, MCQs can be asked. Okay. Now let's talk about, we have spoken about this particular case, right? We have discussed this case. Imagine that person got 2 marks. Now let's discuss about this. Person got 2 marks. Which 2 questions could be correct? Question number 1 and 10, question number 3 and 4, question number 5 and 6, question number 1 and 5. Oh, it's very difficult. Let me just at least calculate the total number of pairs, unique pairs. So using this formula, I can calculate it. Here the x equals to 2. Okay. This way 45 choices can be there. 45 ways. There are 45 ways that person can get the 2 correct answers. Okay. उसका पहला और 10वां क्वेश्चन सही हो सकता है, पहला और तीसरा, पहला और चौथा, second and fourth. 45 total choices. Okay. Now, here what is the probability of success? 0.2 raised to 2. Because 2 times he got the success out of 10 trials. Failure, he got 8 times. If you multiply this 3, you'll get the probability. So what is the interpretation of this? What is the interpretation that Pat has secured 2 marks out of 10? Read the probability figure for me. How do you formulate a sentence using this probability? Take your time. Ravi Kiran, I have shown that number of choices. Ravi Kiran, please, if you remind me at the end, I'll show you again. Okay? I've already discussed that. Got this? Chances are 30%. Correctly said, Aishwarya. Yes. Now, if I twist my question, tell me the possibility that he may get up to 2 marks. Up to 2 marks. Tell me the chances that he would get up to 2 marks. Up to 2 marks. Nay, up to 2 marks. That means he can't get more than 2 marks. That's a Rajdeep, that's a probability that he would get exactly 2 marks. He would get exactly 2 marks. You need to add this up to 2 marks. You need to add this 3 values. Now, tell me the possibility that he would get less than 2 marks. Less than 2 marks. Tell me the possibility that the pet will secure less than 2 marks. Less than 2 marks. Piyush, Leena, Ankita, yes, you are correct. All of you are correct. Superb. Exactly 7 marks. Tell me the possibility that Pat will secure exactly 7 marks. Tell me the possibility or tell me the chances that Pat will secure more than 6 marks. More than 6 marks. More than 6 marks. Great. 9% chances. Chances are very less. Superb. Aishwarya is correct. The probability is 0.09. Aishwarya, probability, either you just put the percentage or put the probability. Okay. How did we arrive at Priyanka is asking, likewise, we have to do it for all. So X equals to number of correct answers are 3, let's say. So the formula is X equals to 3. We need to find out the probability. N factorial divided by X factorial, N minus X factorial, multiply by probability of success, multiply by probability of failure. Okay. So here number of trials are 10 because 10 questions he's going to answer randomly. But 3 marks, that means 3 answers. He must have given 3 answers correct. That means 7 answers wrong. Probability of success, matlab 0.2 is the probability of success, and he got 3 answers correct. Probability of failure, which is 0.80, and he got 7 answers incorrect. Okay, 10 multiplied by 9 multiplied by up to 1. Okay, 8 multiplied by 7 up to 1. 3 multiplied by 2 multiplied by 1. This is a 3 factorial. Now 7 multiplied by 6 multiplied by up to 1. So 7 से लेके यहाँ तक का हिस्सा कट, यहाँ से इतना हिस्सा कट. So 10 multiplied by 9 multiplied by 8 divided by, this is very lengthy process actually. Okay, 3 threes are 9, 2 4 twos are 8. This is going to be 10 multiplied by 3 multiplied by 4. How much it is? 120. This is how 120 is written over there. इस तरह से 120 यहाँ पे लिखे गए हैं, उसी तरह से हर जगह पे। ओके, now this is about the 120. So this is what explanation of this part is 120. This part is 120. We need to multiply with this. So this is 3 times. I mean, the multiplication will go up to 3 times. 0.20 multiply with 0.20 multiply with 0.20. And this is going to be the 7 time, I mean. 7 times, okay? So let me just show you the shortcut in Excel. Here Excel mein you can do one thing. Agar ye expression if you want to derive, then there is a shortcut key in Excel. Say for example, I want to find out this square, I mean square of 2. So 2 ka square, 2 raised to 2. If I want to find out, let's say 2 raised to the power 5. So 2 raised to power 5. 2 multiplied by 2 multiplied by 2, 5 times. 32. So likewise, here, what I have done, this. Can you observe this? Abhishek, I'll answer that. Because this is like in MSc, I've studied all this manual calculations and I wanted for a shortcut. That's why I attracted towards softwares. Like softwares can at least ease our job, particularly that can reduce the pain of manual calculation. Okay. So I'll provide this file. You just look at this. This is nothing but P of X is a multiplication of all. Okay. So this way the probabilities can be calculated. Now, oh, this is a pet example. Pet example is this. Here the pet example is this. Okay. Priyanka, in exam, the multiple questions are there, right? Don't worry about this. These are the very easy concepts. You'll understand. Don't worry. Patiently, you just learn it. You'll get this. Don't worry about this. These are very simple calculations. And most of the people have a fear of mathematics, but try to understand. You have been studying this mathematics since so long, from standard 1. Okay, just little bit understanding with patience is required. Okay, nothing else. Okay, don't get afraid. I mean, you'll get this. I know that people, all of you can at least do this. Don't worry. Now let me just copy this graph. So where is this? So this is what? This is a probability curve. Okay. So these are the probability curve, and what exactly I did. So I plot the probability figures on a graph paper. Okay. So these are the question numbers. So one answer is correct, 2 answer is correct, possibility that the 4 answer is correct, 6 answers are correct, 8 answers are correct, 10 answers. These are the percentages. These are the actually chances. Okay. So chances equals to probability multiplied by 100. Okay. When I plot these, this is what the curve I got. And this curve, you'll observe that it's skewed. Okay, that is a skewed curve. Skewed matlab kya hota hai? This is a skewed matlab on right hand side, this is stretched. This is a right skewed curve. Right skewed curve. Because it's stretched on the right hand side tail part. This curve can be said it's skewed on the left hand side. Why? Because left hand side tail part is stretched. Okay. So either if we have 10 observations, here more than 10 observations would be there. Okay. take example of this. After this, 1, 2, 3, 4, 5. Here we don't have that on this side. That's why it's a right skewed curve. Can you understand? And the function of this is, so let me just talk about this. The binomial probability mass function of this graph is P of x n factorial divided by x factorial n minus x factorial, okay, p raised to x q raised to n minus x. बड़ा ही simple है, very simple. Is it? Is it? Veena is saying it's not. Veena, look at the chat box. You are the only one who is saying no. It's okay. If you have any doubt, you can ask to me. Okay, we'll make it simple for you. We'll make it simple for you. Don't worry. Okay. 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 Let's go back to let's refer the book actually. What is written? So here you can say that discrete versus continuous distribution. The story is given that discrete distribution is dealing with the discrete observation, continuous distribution is dealing with the continuous observation, and discrete distributions are like the mean and the variance and the standard deviations are different. The first is binomial distribution. Okay, let's see the binomial distribution, which is on the page number. Okay. Okay, this is a binomial distribution example, I guess. No, I guess this is not. Okay, these are the discrete distribution, and then they haven't talked about the binomial. Okay, this is a binomial. Okay. So the first assumption is each trials are identical. I mean, you can find a relation that, okay, let's say I have tick marked the first question randomly. That is totally, independent of whatever the subsequent questions I'm going to answer randomly. Okay, so each trials are identical. Okay, totally independent of each other. Trials has only two possibilities, as we have discussed already. Each trial is independent of previous trials. Okay, now this is the terminology that we have understood. These are certain examples. A study conducted by the Employment Benefit Research Institute showed that the 14% workers feel very confident that they will have enough money to live comfortably in the retirement. What could be the reverse opinion? They are not comfortable. Okay, so that's why there are exactly two different opinions. Suppose 16 workers are randomly selected. If the survey is accurate, what is the probability that the exactly 6 will feel that, okay, they are very confident, okay, and they will have enough money to live comfortable life in the retirement. Okay, so this is how this can be done. Okay, so these are the examples where the binomial distribution can fit in. Solving the binomial problem, okay, they have explained in a same manner that I try to explain. Okay, now we are going to talk about, so these are the probabilities. They also try to calculate, okay, this is okay, here I got opportunity to at least mention that, so in the binomial distribution, the mean and the variance can be calculated differently. Okay, now don't ask me why, because this is theoretically derived, so you just accept it. So if your data follows, okay, if your data follows binomial distribution, your mean can be calculated using this formula, n into p. 10 trials multiplied by probability of success. Okay, this is a standard structure of mean. Here trials are 10. So mean is what? There are 10 times that Pat will guess the answer. 10 times Pat will guess the answer. And the probability of success is this. So what is 10 multiplied by 0.2? Tell me. The average answers correct can be 2. Average number of answers. So anyone, apart from Pat, anyone who is going to do the, you know, do this kind of guesswork in order to mark the answers, maybe randomly 2 answers are correct. Why 2? Look at the possibility for that. Look at the possibility of 2 answers correct. It's highest. It's highest. Okay. Look at the curve. Look at the curve and tell me the possibility of exactly 2 answers are correct. It's on the pick. So highest probability is this, that person in a random guesswork for 10 questions where each questions are having 5 options, okay, out of which 1 is correct and 4 are wrong. And if we apply a random guesswork, then normally we can get 2 marks. That's how we can at least proceed. Now variation can be occur based on your luck. So variation is what? So here variation is under root of NPQ. Variance. Oh, it's a standard deviation, okay? N multiplied by P multiplied by Q. So total number of answers multiplied by 0.2 multiplied by 0.8. Tell me how it is. I mean, what exactly the figure is. Yeah, Excel may, if you do it, it's like much easier. Equals to 10 multiplied by 0.2 multiplied by 0.8. Okay, equals to SQRT is the function to find out the square root. Simple. Veena, Karishma, all of you, what? A square root. We need to find out the square root also, right? Karishma is correct actually. 1.26 is the way, is the standard deviation. Okay, the variation could be there of 1 marks. Okay, variation could be there of 1 marks. Okay, it's not like that okay, if I am tick mark, if I start tick mark, let's say if I start tick mark the answers, okay, if I start, let's say, marking the answers, then I get exactly 2 marks. I may get 1 mark. Possibility is there because the variation is of 1.26, almost 1 marks. The variation is there. Okay, clear? Now this is when the sample size, what is the sample size here? What is the sample size here? What is the sample size in experiment? 10 times. Okay, 10. Now, the moment you increase the sample size, look at the change in the graph. So this is an example, PET's example. I really don't have time to at least discuss the 2 more examples because we have some more distributions also. Actually, in my PPT, there is a, let me just quickly take this example. So this is a leading brand of dishwasher detergent, has 30% market share, and a sample of 25 dishwasher detergent customer, okay, was taken. So sample of 25 was considered. What is the probability that the 10 of your customers would choose the leading brand? So in the market में से 30% लोग ये detergent brand चुनते हैं, ठीक है? So because that the market share of this detergent brand is 30%. If we, let's say, select a sample of 25, what is the probability that 10% of the fewer customer will choose that particular leading brand? So your N is 25, probability of success is 30%, 0.30, because market share is 30. So you can imagine out of 100 customers in the market, 30 customers are expected that they choose this particular brand. Okay. And you may imagine 70%, or let's say 70 people out of the 100 that they won't select this brand. So probability of failure is dependent on these 70. Okay. So probability of failure, here probability of failure is what? Person won't select the brand. That's how you define the probability of failure, which is 0.70. Okay. Okay. Now, here the sample size is what? Sample size is 25. Look at this graph. Look at this graph. Compared to this. Compared to this is less skewed. This one is less skewed. When the sample size is 25, let's check it out. Let's check the effect of sample size on this skewness. Now the third example, I do have a third example in which if I plot the probability figure, this is 100 actually. So let me just copy this probability curve. Now this is a probability curve for n equals to 100. This looks much better. So based on this kind of phenomena, this kind of this kind of behavior of the probabilities in case of binomial, scientists found out that as you increase the sample size, okay, as you increase the sample size, curve will look like a normal. Gradually, curve will become normal. Okay. Gradually, curve will become normal. Okay. So this is called binomial approximation of normal. This is known as binomial approximation of normal. So when you increase the sample size, okay, curve will gradually look like normal distribution. Okay. Sumit is asking that what is the explanation of skewness? Skewness is like a tail part is stretched due to high frequency. So here the frequency, maybe more number of points are falling compared to this part. There could be two tail part, left tail and the right tail. Okay. So here more numbers would be there compared to this. So this is called right skewed. More observation would be falling into this region than this. Okay, that's how to draw the curve in Rajiv. Can you ask that question at the end? I'll show you. Don't worry. Let me just do it right now. Chalo. So once you calculate the probability, Rajiv, you have to select this two array. Okay, and then simply select this. Go to the recommend. Go to the insert menu. Go to the recommend, and then this. Okay, Rajiv. Yes, Sumit. Yes, that's what I want to tell you. Mathematical justification, I require some more time, Sumit. Skewness ka formula. Mathematical justification requires some more time. But I have to discuss some more distributions. So let me just, I hope the conceptual clarity you got. Sumit, I hope conceptually you are clear. Because skewness and see, even the mean and the variance formula would be different from distribution to distribution theory. Now we'll study, okay, this is a software. At the end, if I get time, I'll discuss the, SPSS, how to at least deal with the binomial data in SPSS, okay? So please remind me at the end. Now Poisson distribution. So this is a small history of Poisson distribution. You can at least read it on, Google even. So this was invented in somewhere between 1781 to 1840, okay? And paper got published, I guess, uh, who distributed the fundamental in the paper in year 1837, okay? Sumit, I'll talk about it. I guess this is not the right time, okay? Okay, Sumit. So I guess all of you have my number, or let's say Gmail ID. If you have any discussion, please go ahead. Okay. So discrete, this is again a Poisson distribution is also a discrete distribution. That means it deals with the values like 23, 40, 45. These are the discrete figures. So Poisson distribution is also dealing with the discrete values. Okay. That describes the rare event basically. Okay. Rare events describe the rare events basically. Okay. Now the occurrence of each event is independent of other events. That is like very similar. That was the case even in the uh, binomial event. Okay, the number of occurrences in each interval can range from 0 to infinity. Okay, the number can be 0 to infinity. That means trials are not fixed. Okay, trials are not fixed. That means in binomial trials were fixed actually. Okay, so point number 5 is suggesting that only. So example, what could be the situations where this particular Poisson distribution can fit in? So number of telephone calls per minute at a particular office, number of hazardous waste site per state in India, number of sewing flaws per pair of jeans during the production, number of times tire blows on the commercial airplane per week. Airplane per week. These are the standard examples which are given in your book also. Okay, let me just at least go through your book. I hope you got clarity about how mean and the variance can be calculated in the case of binomial distribution. Okay. Now, this I have already discussed. That okay, this is a Poisson distribution. Look at the same examples being quoted. The same situations being quoted actually. So number of times the tire blows on the commercial airplane per week. Okay. So this is the formula of Poisson distribution. Okay, how Poisson distribution is different from binomial. Okay, so here we studied, so here the trials are not fixed. Here the time is fixed. Let's say for 1 hour we just keep observing, or let's say it's just like that way. So let's say in binomial case, being a manufacturer of electrical bulbs, before I conduct the experiment, I have to mention in my design of experiment that, okay, I'm going to at least make an assessment of 100 bulbs. Okay. The time is not fixed, but I'm going to inspect 100 bulbs and their life, whether they are functioning or not. So trials are fixed one by one. In the 100 trials, I'll at least check all the bulbs. Here, the thing is different. In 1 hour, how many, I'll at least inspect the bulbs that I can do. Okay. So here I have putting that condition that, okay, I have a 1 hour of time. In this 1 hour, I'll at least try to inspect the bulbs. Okay. I don't know how many, but as much as I can do. Okay. So let's say I am standing, I have installed the camera. Okay. At nearest, let's say, what you can say, zebra crossing. So I am going to observe that how many people, they just, when the red light turn on, how many of people just park their vehicles on this kind of zigzag line? How many of people, they just park their vehicle on this zigzag line? This is actually a stop line. Okay, here, before that, you have to stop your vehicle. Okay, some people, I have seen that here. I have seen some of the people. So when the red light signal gets off, they just park their vehicle just like this way. So let's say in 1 hour of time, I have installed the camera. So in the footage, I'm going to observe that in that 1 hour, let's say 9 a.m. to, let's say, 10 a.m., I'm going to observe that how many people, they have violated the rule regarding a cross line or the stop line. Okay. So here in this case, time is fixed. Trials are what? So within that time, how many trials can be possible? I'm at least going to check those trials. Here, trials are not fixed in that way. Okay, understood? Understood? Yes or no? So look at this. The Poisson distribution describes the occurrences of rare events. In fact, the Poisson formula has been referred to as a law improbable events. For example, serious accidents at the chemical plants are rare, and the number of and the number of month might be described by the Poisson distribution. The Poisson distribution often used to describe the number of random arrivals per some time interval. Okay, and number of arrivals per interval too frequent. Okay, time can be reduced enough so that the rare events of the occurrences is expected. Okay, so here the, okay, so within a time duration, we just observe the rare events. Okay. Okay, now this is the formula. Let's try to understand what is this. Says P equals to lambda raised to x. Okay, uh, to x, oh sorry, e raised to minus lambda. X factorial. This is a probability. Probability that one accident has taken place. Probability that one person, park the vehicle on the cross line or the stop line, okay, while signal turned off. Okay, so X is showing the accidents, number of violations, and such figures. Is the lambda is the average. Lambda is the average. Okay, so this way it's working. Okay, let's see how that can be. How using this particular formula you can at least calculate the probabilities. Okay, so just understand this particular example. Bank customers arrive randomly on the weekday afternoons at the average of 3.2 customers every 4 minutes. This reminds me 2 months back, actually, when I at least when I took a visit to nearest Bank of India branch. So they just due to COVID, they asked us they just inform us that okay, only 4 people can go inside the bank premise. Okay, so so I was standing in the queue just outside the bank premise, and they used to allow only 4 customers in their premise, okay, at a time. So let's read this example again. So bank customers arrive. So I had taken that visit after 2:30. Okay. So bank customers arrive randomly on the weekday afternoon at an average of 3.2 customers, roughly 3%. What is a 3.2%? 3 persons every 4 minutes. Within a 4 minutes of, or let's say if you in the afternoon time, whatever time interval you choose, whatever time interval you would say, in the 4 minutes of time span, you can expect 3 customers are present in the bank. What is the probability that having more than 7 customers in 4 minutes? This is like something rare event, okay? Because the data is showing, the data is revealing that normally in the noon time, within a bracket of 4 minutes of time, okay? In morning, I mean in the afternoon hours, okay, you may choose any bracket of 4-minute span, okay? Then in those 4 minutes, it's likely to observe 3 people present in the bank. This is what their past data is saying. So here the average is what? Average is 3.2. So lambda is long run average. Lambda is called long run average. Okay. Customers every 4 minutes, 3.2 customers. X is number of occurrences per interval. So observe this question. What is the probability that 7 customers in a 4 minutes? More than 7. X is more than 7. Okay. That means lambda raised to x e raised to minus lambda upon x factorial. So 3.2 raised to 7. This is only for 7 we can calculate. Okay, so we need to at least understand the table just like this way. Okay. Number of customers can be denoted by x. 0 customers in the 4-minute bracket. Okay, in the 4 minutes of span, let's say 0 people present, 0 customers present in the premises. Lambda raised to x, we are dealing with the numerator part. Okay, so right now lambda raised to x, we are dealing with the numerator part. The numerator में है lambda raised to x e raised to minus lambda, और denominator में x factorial है. So this way lambda raised to x can be identified by this way. As I have shown, lambda is constant. It's a long run average based on the past data. So they observe that in any 4-minute afternoon time span, okay, you may observe 3 people on an average. 3 people will be there. Okay, e raised to, okay, exponential. There's a function called exponential. E raised to minus multiply by v3. Okay, either you just put it here minus 3.2 minus 3. 3.3. I have done 3.3 actually. Okay, you can do it like 3.2. Okay, this way. So e raised to minus lambda would be constant for all. Okay, Now you may ask me that we haven't at least given that clue that up to how many customer we need to calculate the probability. Okay, what should be the highest number of customer, okay, had already been observed in a 4 minutes of span. From the past data we don't have that information, that in a 4 minute span the highest number of customers being observed. We don't have that data. So what is another way to do, or let's say how we can address the same issue in another way? So in another way, what we can do is we'll stop calculating probabilities for the number of people, for the present number of people. Okay, just a second. Please, can you just expand this. Okay, so the answer to that question is up to what we have to make, we need to calculate, up to what number of customers we need to at least calculate this kind of things. First we need to derive the numerator part and then we need to calculate the denominator part, but up to what? We haven't given any information from the past data. So the answer to that question is, okay, you need to keep calculating the things, keep calculating the probabilities for the number of customers, okay, till the time you get the 0.000000 probability, okay, for any number of customers. Okay, let's say for 16 number of customers you got 0.000. For 15 it's like 000. Now 12 onwards there is no much deviation. There is no deviation at up to 4 decimal place. There is no deviation up to 4 decimal place. And after 14 there is no deviation up to 5 decimal place. So this is a situation. This is the answer. Okay, whenever you observe probability which is very close to 0, stop at that point. Okay, stop at that point. Whenever you observe probability of any observation is like very close to 0, stop at that time. So here we have closed at the 16 number of customers, which is very rare event, very rare event, that in a 4 minutes of span in that particular bank, if you observe 16 customers, is just like a rare event. Okay, that's what the interpretation is. Yes, Tamsa, you are saying that it's not clear. What is not clear? It's not unlimited, in that has to be bounded by time. Here the observation period is fixed. In that observation period you may observe n number of defects. Aishwarya, the answer to your question is here. Sorry. So answer to your question is, Aishwarya, here the number of time is fixed. In that time you can imagine n number of events. Aishwarya, many times you have to calculate the average. That's why. Probability. You won't get the probability, Aishwarya. What is the probability that more than 7 people would be there based on the average? Can you answer that? What is the probability that at a time 7 people are there in the 4 minutes of bracket? Can you answer that? No, Aishwarya, you can't answer me. If you can explain mathematically, just tell me. Based on the simple average figure, how can you at least answer that? That within a 4 minute of span, let's say 5 people could be there. Tell me the probability of this event. Mathematically, it's not possible. That's why we are using this Poisson distribution. Okay. Now, factorial denominator part is factorial. Okay. And combining this 3, we can at least find out the probability. Now, our question was 7 or more. Okay. In one bracket of 4 minutes, particularly in the afternoon time, tell us the probability that 7 customers can be present in a bank. For that, we need to find out the summation of this is 7 or more. Yeah, only 7. More than 7. Okay. Give emphasis on the word more than 7. So we need to find out the summation. We need to consider these are the cases. More than 7, that means starting from 8. Let's say in a 4-minute bracket, exactly 8 customers might be present. Let's say 9 customers might be present, 10 customers, 11, 12. Okay, these are the possibilities. And we need to add the probability for this possible number of customers. The probability is 0.01. That means 1.6% chances are there. Okay, coming back to Aishwarya's question, when we have a probability, when we have an average value which is a 3.2, okay, we can make an assumption that the chances of this event is very rare. But okay, coming back to Aishwarya's question, yes, chances when we have a long run average, we know that roughly 3 persons are there in 4 minutes of bracket. Okay. Now they ask us to find out the probability that in 4-minute bracket, particularly in the afternoon time, what are the probability that more than 7 person would present in the bank? Chances are rare, very less. Okay, that's why we have done this probability of 8 customer plus probability 9 plus 10 plus and so on. So it's 1.6% chance and the probability is 0.0616. Okay. Any doubt? Here we can take a break of 2 minutes. If you have any doubts, you can ask to me. Aishwarya, that cannot be done exactly. Theoretically, that cannot be done. I mean, if you Poisson PMF take accounts the pattern of probabilities. Yes, PMF take care of the probabilities. Yes. Yes. Aishwarya is asking that PMF takes the account of probability patterns. Yes, Aishwarya. Yes. E is a constant. Karishma is asking what is E? What is pi, Karishma? What is the value of pi? 3 point? Tell me. E is a constant. 3 point? Who will tell me the value of pi? 3.14. Yes. Okay. That's why E is a constant. It's an exponential value. You can say that it's an exponential. You can say exponential. Exponential constant. Okay. Okay, Aishwarya? Oh, sorry. Okay, Karishma? Okay. Any questions? Here we are taking 2 minutes break. So any questions regarding these 2 discrete distributions? I hope you understood this. उसका ग्राफ कैसे बनता है ये भी देख लेते हैं. Let's see. Let's discuss the graph of this. This is the graph. Can you see this? It's not exactly normal. अब सात कस्टमर से ज्यादा वाले क्वेश्चन में 11 से ज्यादा कोई भी कस्टमर आते हैं उसकी प्रोबेबिलिटी इज ऑलमोस्ट नील और वेरी क्लोज टू जीरो. सो वी कैन calculate up to 13 or 12 of, though I calculated for 16 because average customers from the past data is 3. The highest number of customers cannot be more than 12 or 13. 10 तक मुझे प्रोबेबिलिटी कुछ मिल रही थी, 11 से तो मुझे ऑलमोस्ट जीरो ही मिलने लगी, और 13 15 कस्टमर 16 पहुंचते पहुंचते तो इट्स लाइक बहुत 0 0 0 0 हो गई. So I need no, I should stop calculation here. Got this? Karishma, I know that, but I'll at least explain. I'll explain by just give me at least 1 or 2 days. I'll explain. Okay. Real life example. Yes, of course, we'll take real life examples. Sorry, Lena. Actually, okay. Second example. Yes. This one is the second example, Lena. Sorry, 4th time you're asking, but I'm finding it really very difficult to at least discuss the formula and keep my eyes on the chat box at the same time. So that's how it's happening. Okay, tell me, Lena, what's about this second example? Tell me, Lena, what is about this second example? I mean this. Do you want to refer this formula? Okay, whiteboard. Yes, this is the Lena. This is the thing, Lena. Tell me. What exactly you want to know? Tell me about the second example, Lena. Tell me the exact thing so I can at least answer you that way. Let me just show you the question of the second example. This is the second example. This was the second dishwasher, right? Aishwarya is writing, sir, can we please have more real life examples? Of course. Okay. I guess you say that done. Okay. Okay, Lena. If you have any doubt, you can at least, later on, you can at least ask to me. We'll have a recordings also. So once you just go through recording and then if you can't understand, you can always write it to me, right? Let me just go ahead. I mean, up to here, I have discussed these 2 examples. Now let me just, so here is the Poisson example. There is one more distribution, which so here they say that Suppose that during the noon hour, okay, this is the same example. Okay, this is the same example that I have at least discussed with you. So no need to at least discuss this. So here you just remember that the mean is lambda, okay, and the standard deviation is under root of lambda, okay. So in our case, mean matlab average expected customer, average, or let's say expected customers in a 4 minutes of time are lambda, which is 3.2, which is equals to, you can say roughly three people. You can find 3 people in the 4 minutes of bracket during the noon time. If you find the variation, if you find the 4, 5, 6, what are the possibilities of standard deviation? So variation can occur of root lambda. What is the root 3.2? Roughly 1%. Check it out. Is it? Roughly 1%. Is it? Am I correct? Yes or no? Yes or no? Am I correct? Oh, 1.7 day. That is roughly 2%. Got this? Now, the next point in this is, again, this distribution also act like a normal distribution when you at least go for a larger sample. Okay. So again, by Poisson approximation, normal exists because the moment you collect more and more data, and this way, if you, let's say, increase the sample size, then your Poisson distributed data will look like normal. Okay. Now the filling the blanks is like very simple. The Poisson formula has been referred as a law. I mean the law of rare events. In the Poisson distribution, lambda is long run average. Okay. The Poisson distribution is derived from binomial. In the distribution, each occurrences is dependent on each other. No dependence. I mean, no, they are completely independent. Okay. Now this is a hypergeometric distribution, amazing distribution. Okay. So here it's like a discrete distribution. Please take a note. This is also a discrete distribution, just like a Poisson and the binomial. Each outcomes are consist of either success or the failure. Sampling is done without replacement. Matlab, if one item is like say defective, you can't replace that. You just observe that item is defective. No need to replace with the correct, I mean the okay item, or let's say a functioning item. Okay. Number of successes in the population. Okay. We just try to notice the number of successes, and then N, capital N is nothing but the population size. That has to be finite. Okay. Finite means countable. Okay. Let's take the example and then we'll. So this is this is a way to find out the probability. This is a formula to find out the probability of any event in hyper geometric distribution. Okay. Capital N. Of course. Shravanthi, I'll do that. I'll do that. Okay, Shravanthi, I'll do that. Okay. So N denotes, capital N denotes the population size. Small n denotes the sample size. capital A denotes the number of successes in the population. Small x is showing about, that shows the number of successes in the sample, and the sampling is done without replacement. Okay. Now let's take an example. Suppose 18 major computer companies operates in United States, and the 12 are located in California's Silicon Valley. If three computer companies are selected randomly from the entire list, what is the probability that one or more the selected companies are located in Silicon Valley? Here the trials are not there. Or there are some trials. This is just a fact that, okay, 8 major companies, we are talking about 18 major companies, sorry, 18 major companies, and they are based at this US's, Silicon Valley, okay, California Silicon Valley particularly. That means 12 companies are located in California Silicon Valley. What about the other 6 companies? They are located in the different places than the Silicon Valley. Okay. Now, what is the probability that one or more selected company are located in Silicon Valley? Okay, let's do it. 18 companies. Okay, what is N? 18 companies. This is what? A finite population of computer companies in USA. Okay, so out of 18, okay, what we have been given? What we have been given? Probability of success. We need to define the probability of success. What is the probability of success? Here the probability of success is companies located in California. Okay, California's Silicon Valley. Okay, Silicon Valley. Okay, 3 computer companies are selected randomly. Now random selection. Random selection. That means sample equals to sample of 3 companies. What is the probability that one or more probability that one company is from Silicon Valley, probability that 2 companies are from Silicon Valley, probability that 3 companies are Silicon Valley? This way you can at least understand the statement, the last statement, probability that one or more of the selected companies are from Silicon Valley. So probability, this can be mathematically expressed that the selected companies greater than 1, okay, selected companies which are from Silicon Valley, okay. So X is selected company located in Silicon Valley. Let's try to find out probability that selected companies, okay, More than one selected companies are from Silicon Valley. Now I'm asking that you just tell me the different probabilities of this. Maybe out of three, one company is from Silicon Valley. Maybe two companies are from Silicon Valley. Maybe three companies are from Silicon Valley. It cannot be P of x equals to 4. This is not a possibility because n equals to 3 only. In the sample, we are going to select the three companies randomly. तो ये सबसे बड़ी पॉसिबिलिटी है, ये सबसे छोटी पॉसिबिलिटी. ठीक है. नाउ यू जस्ट टेल मी इस सिचुएशन में क्या होगा. लेट्स अंडरस्टैंड दिस. वन कंपनी इज फ्रॉम सिलिकॉन वैली. ठीक है. वन कंपनी इज फ्रॉम सिलिकॉन वैली. You need to understand the formula which is given there. इसका फॉर्मूला ये है. Okay, let me just write the formula. Okay, this is the formula. What basically it's telling us, one company is from Silicon Valley. मतलब उसका सिलेक्शन कितने में से होगा? 12, because total 12 companies are located in Silicon Valley. So let's say out of 12, one can be selected. Anyone randomly can be selected. Multiplied by, because total we have to select the three companies. So let's say out of 6 companies which are located other than Silicon Valley, let's say 2 companies can be selected, because we have to select 3 companies which is given in the question. और यहाँ पे total 18 companies में से 3 का selection. So this is how we can explain probability that one company is based at Silicon Valley out of 3 random selections. तो यही तो है n-a. Okay, same way we can derive for this. Here, out of 12, let's say 2 companies are chosen from Silicon Valley. That means only one company has opportunity to be selected, okay, which is not located in Silicon Valley. Now the third possibility. What is the third possibility? Let's say all companies, all three randomly companies selected from Silicon Valley. That means none of the other companies are selected from other locations than the Silicon Valley. Yes, Aishwarya, but that way I don't know how many of you can understand this. That's why I have chosen the way which is prescribed or the way which is given in your book, Aishwarya. I need to follow the book. Otherwise, most of you will at least confuse. That's why. See, I have to carefully discuss with you. Okay. So I'm going parallelly with the book. Okay. So the chances can be calculated like this way: 0.22, 0.48, 0.26. So 97% chances are there that if you randomly select 3 companies out of 18, then more than one company could be located in Silicon Valley. The answer is 97% chances of that event. Now you just tell me, what are the chances that, what is the reverse probability? The probability that the one or more than one company is not located in Silicon Valley. Tell me the probability that, yes, correctly said, correctly said. Amazing. That means you've understood this. Okay, one more distribution I would like to discuss with you. Now it's a continuous distribution. Okay, this is called uniform distribution. So what is a basically uniform distribution? Let's try to understand through one example. Okay, through one simple example, we'll try to understand. Then we'll at least understand these formulas and all. So this is the example. The amount of gasoline sold daily at a service station is uniformly distributed. They found out that this is uniformly distributed. We'll find the logic. I'll tell you the reason why they found that this is uniformly distributed. With a minimum of two, so this is the daily, this is a minimum possible value of sold gasoline, and this is the maximum possible value of cells of a gasoline in a day. Okay, so here we have a range, so this is a continuous. So here the continuous discrete distribution will be applied, right? Discrete figures are not there here. Okay, now can we define the range? Can we define the range? What is the range? So this is called uniform distribution. Here, these are the observations. These are defines the range. So minimum production could be 2000 gallons. Maximum maximum cells. This we are discussing the cells figure. Minimum cells can be 2000 gallons. And the maximum cells can occur in 5000 gallons per day. Okay. Now, this is a minimum cells. This is a maximum cells. Okay. So the range has already been identified. So range has already been identified. Okay. Based on the past data. Based on the past data. We don't have the past data, but based on the past data, they have given the range. Okay. Now we need to find out the probability that this cells would be between 2500 to 3. Earlier we used to calculate that x equals to 1, ठीक है, x equals to 3. अब क्या हो गया? अब x is between 2500 and 3000. Now this kind of expressions will be there. Okay. So now we need to identify the possibility. So based on the range, let's define the highest possibility. Okay. So this will be the peak of the curve. Why? Because here we have captured 1 divided by max value minus mean value. So 1 divided by 5000 minus 3000. So 1 divided by 2000 is what? Basically, tell me. Oh, sorry, 2000. 2000. 1 divided by 3000 is what? So this is P of X. So we have defined the range. I mean, we have defined the maximum possibility. So this is a peak. Yes. So this is a P of X. This is a PDF. Here we call the PDF. The function which is giving, which is helping us to find out the probability. The discrete figure में उसको कहा जाता था probability mass function. और यहाँ कहा जाएगा probability density function. क्या कहा जाएगा? Probability density function. So probability density function तो we have identified based on the maximum possible value. Okay. So this is our P of X, which is 1 by 1000. Okay, so this is the biggest possibility. Okay, now we need to identify this area. The cells is between 2,500 gallons to 3,000 gallons. We need to identify that. It's okay. We can do it very easily. So why don't we at least take a difference between 3,000 minus 2,500. Here we have two values, but we have a range also, bigger range also. From the past data says the maximum possibility is this. So this is a current possibility, or you can say this is the favorable number of cases. These are the total number of cases, just like that way, analogically. So this is what? The current possibility, and this is past biggest possibility. The cells was as low as 2,000 gallons. Cells was as high as 5,000. This is the current possibility. Cells would be somewhere between 2,500 gallons to 3,000 gallons. So what is the probability of this? Solve this and tell me the probability. Chances, कितने प्रतिशत chances हैं इसके कि कोई एक random दिन पे the cells would be between 3,500 to 2,000. Chances are 16%. Yes. Now let's discuss the formula. So based on the past minimum and maximum value, you can decide the peak. Here the peak will be formed in a way that if you compare the peak with the minimum possibility, the lowest possibility, and the maximum possibility, okay? Minimum possibility can be based on the minimum observation. Maximum probability can be based on the maximum observation. Okay. Now this looks like a square area or rectangular area. Rectangular. This is also called rectangular distribution. Okay. And here the probabilities are uniform for many things, right? This looks like a rectangular area. It's not like somewhere it's like this, somewhere it's like this, somewhere it's like this. It's not like that. So based on the graph of the distribution, because it's rectangular in pattern, that's why it's called uniform. Look at this. The probabilities are uniformly distributed over uniform. It's a uniform distribution, right? Now these are the formulas for calculating mean and the standard deviation. So variance can be defined like this way. The standard deviation can be defined like this way. The mean is A plus B by 2. Okay. What is A here? What is A here? Can you tell me the A? What could be A? A is the smallest observation. Smallest. B is the largest observation. Okay. In our case, what could be the mean? 2,000, which is the smallest observation. 5,000, which is the highest cells observed in the past. Divide by 2. 3,000. This is the average cells of a gasoline. Variation. What could be the variation per day? The difference between 5 and 2,000 is 3,000.